Hello all, myself Devendra Itole, working as an assistant professor in ENTC Engineering Department from AISSMS Institute of Information Technology, Pune. Today we are going to study program branching instructions of 8051 microcontroller. These are the summary of program branching instructions depends on the addressing modes of 8051. Here mnemonic and its description is given. In description, PC indicates program counter, SP indicates stack pointer, REL indicates relative, C means carry flag bit, and DPTR means data pointer. A means accumulator. Now let us see all these instructions in detail. First, A call ADDR A11. It means absolute call instruction. This instruction unconditionally calls subroutine located at a specified address. Before the control is transferred to the subroutine, the address of the next instruction of the main program is saved in the stack. The target address of the subroutine must be within 2 kilobytes because only 11 bits of 2 bytes are used for the addresses. It requires 2 bytes and 2 machine cycles. Flags affected, none. Example, A call NEXT next. Move A, Rn. Then L call ADDR 16. It means a long call instructions. This instruction unconditionally calls subroutine located at a specified address. Before the control is transferred to the subroutine, the address of the next instruction of the main program is saved into stack. The target address of the L call instruction is within 64 kilobytes because only 16 bits of the 2 bytes are used for the addresses. It requires 3 bytes, it takes 2 machine cycles, and no flag is affected. I'll call next example. So it will jump to the next label, means nothing but a subroutine call. Then AJMP ADDR 11, it means absolute jump. This instruction transfer program execution at a specified address. The target address of the subroutine must be within 2 kilobytes. Absolute jump instruction range is 0000H to 07FFH. It requires 2 bytes and 2 machine cycles. Example, AJMP NEXT next. Then LJMP ADDR 16. It means unconditionally long jump. This instruction transfer program execution at a specified address. The target address of subroutine must be within a 64 kilobyte because L jump is a 16 bits are used for the addresses, and the memory location from 0000H to FFFFH it allows. It requires 3 bytes and 2 machine cycles. No flag is affected. Example, LJMP NEXT next. Then let us see SJMP REL. It means short jump. The branch destination address is computed by adding the specified sign displacement to the PC. The relative address range for the SJump instruction is 002 FFH, means in decimal -128 to +127. It requires 2 bytes and takes 2 machine cycles. Example, SJMP NEXT next. When the instruction get executed, program counter is incremented by 2 byte plus address, and updated program count will jump to the that destination address. Next, JMP @A plus DPTR. It means jump indirect. The branch's destination address is computed by adding 8-bit unsigned content of the accumulator to the 16-bit data pointer. It requires 1 byte, 2 machine cycles. No flag is affected. JMP at the rate A plus DPTR. Before instruction A equals to 10H, DPTR is equals to 1000H. Program counter will consider the 0500H. After the instruction is executed, program counter will become A plus DPTR, that is 1010H, and the pointer will jump to the data address. JZ, jump if accumulator is 0. This instruction will jump address indicated if the accumulator is 0. Otherwise, it will continue with the next instruction. It requires a 2 bytes and 2 machine cycle. Example, JZ label 1. Same JNZ instruction is there. In JNZ, jump if accumulator is not 0. Okay. This instruction will jump address indicated if the accumulator is non-zero. Otherwise, it will continue with the next instruction. Example, JNZ label 1. Next, JC instruction. JC instruction means jump if carry flag is set. This instruction will jump to the address indicated if carry flag is set. Otherwise, it continue with the next instruction. The branch destination address is computed by adding the signed displacement to the program counter. It requires a 2 bytes and 2 machine cycles. No flag is affected. Example, JC label 1. Same like JNC instruction is there. Jump if carry flag is 0. Means jump if there is if the carry flag is 0. Right? Otherwise, it will continue with the next instruction. It requires a 2 bytes and 2 machine cycles. No flag is affected. Example, JNC label 1. Then JB. J means jump, B means bit. Jump if the content of specified bit address is set to 1. This instruction will jump to the address indicated if the bit in the instruction is 1. Otherwise, it will continue with the next instruction. It requires a 3 bytes and 2 machine cycles. Example, JB P1.0, which is the first IO pin of port 1, comma label 1. So this example means, this instruction means jump if P1.0 equals to 1. Otherwise, it will execute the next instruction. Then JNP. Jump if the content of specified bit address is set to 0. Okay. The branch destination address is computed by adding the signed displacement to the program counter. It requires a 3 bytes and 2 machine cycle. Example, JNB P1.0, comma label 1. Next, JBC. Jump if the content of the specified bit address is set to 1. This instruction will jump to the address indicated if the indicated bit in the instruction is 1. Otherwise, it will continue the next instruction. Okay. It requires a 3 bytes and 2 machine cycles. In JBC instruction, program counter is incremented. If bit equals to 1, then that bit will become 0 and jump to the program counter plus address. So example, JBC P1.0, comma label 1. Now let us see CJN instruction. C indicates a compare, J means jump, N means non, E means equal. It means compare direct byte to the accumulator and jump if not equal. Syntax, CJNE A comma direct comma REL. This instruction compares the magnitudes of accumulator with the magnitude of memory location whose direct address is provided in the instruction and jumps to the indicated address if the magnitudes are unequal. The branch destination address is computed by adding the signed displacement to the PC, means program counter. It requires a 3 bytes and 2 machine cycles. In CJN instruction, if accumulator is not equals to direct address, content of direct address, then jump to the PC, program counter plus REL relative. And if A accumulator is less than means content of accumulator is less than content of direct address, then carry flag will get set, otherwise carry flag will be 0. Example, CGNE A comma 30H comma label 1. Then CGNE A comma hash data comma REL. It means compare direct byte to the accumulator and jump if it is not equal. Right? Here, if content of accumulator is less than immediate data, then carry flag will be set, else carry flag will be 0. It requires a 3 bytes and 2 machine cycles. No flag is affected. Example, CJNE A comma hash 30H comma label 1. Next, CJNE RN comma hash data comma REL. It means compare immediate data to the working register RN and jump if it is not equal. Here, if RN is not equals to data, then jump, and if RN is less than data, then carry flag equals to 1, otherwise it is 0. Example, CJNE R2 comma hash 30H comma label 1. Next, CJNE @RI comma hash data comma REL. It means compare the immediate data to the content of the data RAM location pointed by the register RI and jump if it is not equal. The branch destination address is computed by adding the signed displacement to the PC. Example, CJNE @R1 comma hash 30H comma label 1. Then next instruction is DJNZ instruction. D means decrement. Decrement the specified working register and jump if it is not 0. This instruction decrements the specified address by 1 and branches to the address indicated by the second operand if the result value is non-zero. The branch destination address is computed by adding the signed displacement to the program counter. It requires 2 bytes, takes some 2 machine cycles. No flag is affected. Example, DJNZ R1 comma label 1. So R1 is get decremented if it is not 0. Then he has to jump, otherwise he has to execute the next instruction. Then DJNZ direct comma REL. Here content of the direct address is going to be decrement and jump if it is not 0. Then NOP. NOP means no operation. Here no operation is performed, only program counters get affected. Okay. The contents of the program counters is getting incremented by 1. Requires a 1 byte, 1 machine cycle. No flag is affected. Example, NOP. Last, RET. RET means returns, return from the subroutine. Basically, RET is used at the end of the subroutine A call or L call. The execution of RET instruction brings back the saved address from stack and keeps in the program counter for further execution. It requires a 1 byte and 2 machine cycles. Example, RET. Same, RETI is there. I indicates the interrupt. It means returns from the interrupt service subroutine to the main program. RETI is used by the subroutine called by an interrupt. RETI is used at the end of the subroutine. It pops the return address from the stack and keeps in PC, that is program counter, for further execution. It requires a 1 byte, 2 machine cycles. Example, RETI. Thank you.